Bismillahirrahmanirrahim. My name is Mohammed Shoaib. Welcome back. Today in this tutorial video, we will learn the channel driver blocks in the PCS7. Whether you are the beginner or you are going to refresh your skills, this tutorial video will help you step by step how to configure the channel driver in the PCS7. So there's two type of the driver block. The single process block or the channel blocks, they are used directly by the engineer in CFC by drag from the library and drop into the CFC chart like PCS7 digital input or digital output blocks. The modular driver blocks, they are provided diagnostic information about the hardware. They are automatically inserted by the generate module driver wizard in the PCS7 chart generated by the compiler, whose name begin with an at the rate symbol and are connected to the channel drivers. So in the shortly, we will see how it's look like. So the PCS7 digital input, digital output, analog input, and analog output channel driver blocks. These blocks are called standard channel blocks. They convert raw value into the physical value. The feedback analog input, analog output, feedback digital input, digital output blocks. These blocks are designed specially for use with PA and FF field devices and hard field variables. These feedback block process a physical value instead of a raw value. Then the PC7 counter blocks. These blocks are required for the special applications such as controlling and reading the counter or the frequency values. So here the system architecture of the driver block, how the driver block work in the PCS7 environment. So the control signal from a channel of output module is wired to the motor, and the feedback signal from the motor is wired to the channel of the input module. The signal from the input module is transferred to the process image of the input like PII that is situated on the CPU. So, and after that, the input driver reads signal from the PII and bring into the chart to be used by the control block. So here is the control block is a motor MOTL motor large block is a control block. The control block reads the process value from the input driver. Its logic will be generate one or more control signals. For example, here you can see the start command is generate one more signal, and the output driver read the control signal from the control block from the motor block. The output driver it will read it. The output driver write the control signal into the process image of the output like PIQ situated on the CPU. The control signal are transferred to the output module. The output module convert it to the proper electrical signals. So I will summarize this whole uh, driver block again. Like suppose we have a motor. In the motor, we are getting the run feedback signal. The input module will read the electrical signal from the motor. Then it will write that value in the process image of input PII. Then our PCS7DIN digital input driver block will read signal from the PII, and then it will transfer to our control block, the motor block, and motor block will execute the logic, and after that it will give another command signal, that is a motor start command signal or stop command signal, and then our PCS7 digital output driver block will read that signal, and then it will write that signal value in the process image output PIQ. Then PIQ it will write this signal to the output module, and then it will convert into the electrical signals. So how we can configure the channel driver blocks in the PCS7? So the first step, will update the symbolic name for the digital input module, digital output module, analog input module, and analog output module. After that, we'll open the chart, and inside the chart, we will add the digital input driver, and we will link digital input driver with our input physical input signal. And similar manner, we'll add and link the digital output driver in the chart, and then we'll add and link the analog input driver, and similar manner we will also add and link the analog output driver. And once we add it all, then we'll start the compilation process. So we have to ensure that the generated module driver should be tick marked. So once it's successfully generated, then like that, here you can see at the chart is starting with the at the rate. So these all file will generate. If this file is not generated, it means the module driver is not properly generated. So um, after compilation of the our project, the mode configuration and data exchange configuration automatically will be generated. If it's not automatically generated, in that case we have to manually configure it. So we have to, as you can see it from here, we have to put the mode configuration. As you can see, the third byte, like we have to put it like 80, and similar manner the first two bytes we have to put like as per our input signal. Like if the 4 to 20 is there, we have to put 0203. If it is like 0 to 10 volt, then we have to put it 0108. And similar manner data exchange, we will put the C. So here is the detail of these signals. So let's do it practically, how we can configure the channel driver in the PCS. So we already created this project in our previous tutorial. So if you did not saw the previous tutorial, I will give the link in the description, so you can check that link. So now the first we will add our come in the hardware. We'll add our uh, input and output address. We'll assign some name. So our hardware configurator is open now. So in the previous tutorial, we add one digital input module, digital output module. So first we'll add some analog module also. The first module I will select and drag and drop it here. And after that, I will select one AO module also. Just select, drag and drop it here. So first I will select, right click, edit symbol. Okay. So I will put the name P01 start feedback. Suppose this signal, I'm getting input signal and then the output signal, edit symbol, and Q0. I will put pump 0 start command. Press OK. And similar manner, the I will right click, edit symbol, and then here I will put like the temperature. Click OK. And similar manner, edit symbol, and I will put it like I will put okay pump 01 speed command. Press OK. And so from here, right click, edit property, and from the parameter in the channel, you can either select 4 to 20, 2 wire, 4 wire, it's up to you. You just have to select it, what signal you want. Okay. So for example, I will right click and then object property. I will assign my first channel 2 wire. Okay. And I will assign like 0 to 20 milliampere, or either I can select the 4 to 20. So I will select 4 to 20, press OK, then save and compile. Okay, just click save and compile, and then we'll close it. Okay, so hardware configuration completed. Now open the pump CFC chart. Just open it. So now we will come here in the libraries. Then come here in the PCS7 library version 9.1. Then block template, then channel. And from here, first I will select the digital input driver. Select, drag and drop it here. Okay, so PV in, right click, interconnection to address, and I will select from start feedback. Okay, in similar manner, I will select now the output command, like the and digital output driver, channel driver. Select, drag and drop it here, and PV out, right click, interconnection to address, then start command, and I will link this pump start with the PV in. Okay, and similar manners, I will select PV out with the run feedback. Okay, perfect. Now I will add the analog channel driver blocks. I will go at the page 2. I will select digital analog input driver, select, drag and drop it here. And after that, right click interconnection to address, then select the temperature, and then I will select the analog output. Okay, perfect. And then PV out interconnection speed command. So here I'm just interconnecting these two blocks just for the simulation and the purpose. Okay, just for the simulation purpose. Okay, so I will just connect the output of this block with the input of the command block. Okay, perfect. So now, uh, till now, we add and link the digital input block, output block, analog input block, and analog output. Now I will compile. While you compile, you must have to ensure generated module driver block should be check mark, because if it is check marked in, then the mode and data exchange configuration, it will automatically configure it. Press OK. Okay, as you can see, we after the compile option, here the mode and data exchange automatically link, and but uh, for the output analog output channel driver, we just keep the default setting. That's why here it's not automatically linked. So it's up to you if you want to keep that default setting. In that case, you have to here manually put it. But initially, I did not change this. So there's another way. So here you can like put 3 and you can put it 2. Press OK. Then data exchange 1. So here you can put C. Okay. I already explained this mode and data exchange. So in this case, we select the 4 to 20 milliampere. So that's it. And similar manner here also. Okay, perfect. And now, so either through compile option, you can select the driver uh, block of module, or from here another option also there, chart, right click, chart, and you can also generate module driver from here also. So now I will, as I already changed it, so I will again recompile my changes, and after that we'll download it. So only changes. Okay, so we'll close it. I will open the PLC Sims simulator. And put in the run, and after that I will download the project in controller. Click yes. Okay, Click yes. And here just I want to show you at the rate chart. This is after like generating the driver block. These all charts is generated. Okay, now I will check. Now PLC is running healthy. And first I will go here in the test mode. Yes. And after that, I will select the input module and click watch on. Okay. And press the control key, and then I'll turn on watch on for the motor block also. Okay. For this we can add on. Okay. So here, if I will turn on my first input, so as you can see start command, and this is right now 0. If I will turn on my input signal, so as you can see, I receive the feedback input signal from here. Okay. So I will put it off. So as you can see, we receive the feedback signal once the input signal is on. Okay. And similar manner, here output signal, if I will generate it from here, in that case, we can generate the output signal also. So come over the analog, and the for analog also click over the watch. So our temperature input signal is coming over IW512, and the analog output signal is coming Q512. So it's mean if I will here you can see the input analog input block output I connect with the analog output block. So if I will change here some value, so same value, it will scale it from here. Suppose uh, if I will change any value here, the maximum value is this output will be 100. And here you can also see the scale also 100. So then the same value will come here, and from here it will also go out the same value. So as you can see, I have I IW512, and here my output also QW512. If I will change it anything from here, you can see exactly same thing is reflecting here. So you can see once I will change the it's reflecting both thing is here. Okay. So same thing is reflecting here. So it's mean, so whatever the raw value is coming over the analog input block, then it's scale, and after scale, the output is coming here, and then that output is coming to analog in output block, then analog output block again is scale, and then it's giving again the raw value to the analog output module. So Alhamdulillah, in this tutorial video, we learn how we can configure the channel driver in the PCS7 environment, and we'll also try to configure the digital input driver, digital output driver, analog input and analog output driver in this tutorial. So thanks for watching this video.